Hello, welcome to another video of heuristic algorithms. In this example, we're going to demonstrate again the use of the solver in Excel. And now we present an interesting problem in which we need to make an assignment. In this particular problem, the assignment problem, we need to assign rows and columns. Think of it as maybe arranged marriages in which what we're trying to do is maximize the happiness of the society as a whole. And we have here the brides, or those who would be assigned as brides. These would be those who would be assigned as grooms. And of course, in a traditional society, we would assign one to each one of these. None of them can have more than one, either wives or husbands. And so the numbers that we will have here will represent who is assigned to who. One, if the pair column j row I is assigned, then the value of xi j will be 1, and if it's not assigned, the value would be 0. So here we have an initial assignment in which we use the diagonal of a very simple solution. And here we have the level of empathy or happiness that these couples may have, or in a different situation, an industrial situation. It could be some benefit that we would get by assigning each product to each customer, or etc. So what we have here is a multiplication of these factors times these coefficients, or these decision variables times these coefficients, and this is the total benefit that we obtain. If we add all these values together, we would get a net benefit of 194. What we're trying to do is maximize the total benefit. So the question is, which combinations of these pairs, ij's, would benefit the whole assignment as a global solution? So we can solve these by using the solver, and the solution, or the objective function, is the total value of the benefit, and we want these 4 cells to be my, or these actually 16 cells to be my decision variable. And we're going to have a few constraints. First is the fact that these decision variables have to be binary. That is, they have to be either 1 or 0. Another constraint is that none of them can have more than one wife, none of them can have more than one husband, respectively. So we're going to add another constraint. I missed that. Okay, that's the objective function. Now we're going to create another restraint that says that this has to be equal to 1. Each one of those cells have to be equal to 1, and also all these cells have to be strictly equal to 1. We can say 1.0. Okay, so those are the 3 constraints that we have. We have the binary constraints, and each one should be assigned to each other respectively, and those are the only constraints. The computer should take care of computing some of the combinations. The computer uses a smart algorithm to figure out which way to do it. Again, we're going to assume a linear model and non-negative decision variables, and we can solve it now. And we obtain a solution for which the total benefit for the society would be 214, with the assignment being 1, 4, 2, 3, 3, and 2, 4. Notice that there is a rounding process, but for all purposes it's a 1, and we obtain those values in a very fast way. Now this is a simple problem that it wouldn't be as simple if it was not so small. However, this is the nature of the combinatorial problems. Of course, you can solve an assignment that works as a linear program if we take out the binary constraint. So we delete that constraint and we solve the problem again. We might obtain a different solution. Let's start with a non-feasible solution and see if we obtain a different answer. And we solve, and now in essence this is a pretty robust solution in terms of assigning most of the happiness to each other, or the benefit of varying products to customers in a very efficient way. Not everyone gets the most in both in terms of columns and rows. For instance, here we have a case in which column 4 doesn't get the highest benefit that it could have, because it's getting actually the third out of 4 alternatives. But since that's the best way to get the total benefit for to improve, that's how the solution is to be implemented. So those trade-offs are taken into consideration. In my experience, the solver, especially for integer programming, is not always as robust. Sometimes it could come up with solutions that are not optimal. So treat the solution that you obtain with this solver, the solver that comes with the default in Excel, with caution. Is not necessarily the best tool you can have, but this is how you would use it for integer programming.